Good morning, everyone, and welcome to the fourth part of the Computer Attitude course. Now, today we will mainly deal with the part related to software. So we will see how the software that we had developed, which we had essentially developed in the first two episodes in Snap, can be converted into C and into Python. So as I was saying, we will mainly deal with the software part. Just to briefly recap, I put these slides and summarize so that it's easier to pinpoint where you are. In the first part, we basically looked at Snap along with some general observations on programming. Then, in the second part, we had seen the main constructs, so lift and else. We had also seen the loops and the assignments that we had already actually seen in the first part. Then in the third part, which is the last before this one, we focused on installing the necessary software. So we installed VirtualBox as the virtual machine system, and then installed both a virtual machine with Windows 10 and one with Linux Ubuntu in order to have two systems, which are among their complementary. They practically encompass most of the installations. We had installed a large amount of software, and then we looked at some things about command lines, the terminal, and then also something about networks, also something briefly about web servers and cyber attacks. As you may have noticed, today I am using a different type of computer. I am using a Mac, and this is because the Macintosh and still the Apple Mac OS X, the operating system, is nonetheless a type of computer that is now quite widespread, and I considered it important for you to see it in action directly, even if only in less detail compared to the other two. So what will we see today? First of all, we will see the solution to the directory exercise, the one we left unresolved last time. Then we will see a brief introduction to the copyright issue, copyright and copyleft, and then the main part, the solution to the exercises previously done in Snap, and we will see them in C and in Python with all the various programs we have seen. And finally, we will also look at something I find interesting through the Raspberry, which is a small-sized computer but very interesting, since this fourth part, just like the third, is quite substantial in terms of time due to the various installations. There will be two parts, a 4A and a 4B. So now we will start with 4A. Now, before starting even just with the exercise, however, I wanted to tell you something, and especially start doing something. You see here, VirtualBox is already active, apart from these two virtual machines that I normally use. You see here there is a .ova file. Now, this .ova file is simply the file obtained by exporting the Linux virtual machine from the Windows laptop that was used for the first three parts to perform the recordings. So, what did I do? From the virtual machine, I proceeded to do something like export appliance. You see, it asks me which one I want to export. Here, naturally, there are only these two. And then by clicking continue, he eventually, essentially without any difficulty, it produces for me a VIA file that is quite large. In particular, this file is about 3 gigabytes. Okay. And in this way, I then transferred via a USB stick, because it is less than 4 gigabytes, so there aren't particular problems. I transferred the file onto the Mac using a USB stick so that I could then load the virtual machine here. So the first thing I want to do is load the virtual machine indeed. So you see, I go here. I select on the desktop, I load the file, You see, it finds all the characteristics we set last time. I click import. This import procedure is quite fast, a little over a minute. So it is not a big problem. What is the purpose of all this? Because once today's episode is finished, which is the one with more, if we want, material, some more work related to the software, the virtual machine will be ready and I will make it available. Once the 5th episode is completed, it will be at your disposal together. You see that the material will essentially be this zip that contains all the files we have developed and will develop also with the 4th and 5th episode. There are also the slides and so in addition to this, you will have the virtual machine, not the version from the 8th of July, but the so-called definitive version. So now it should have practically finished. Yes, it has finished. So now let's do a nice thing. Let's put this here. You see that here too there is the multiple desktop system. I start the Linux virtual machine, which will start in full screen. Notice that this computer has a Retina display, which means essentially a very high resolution. See that here it is very small, while the video is full HD, which is 1920 by 1080. These tiny details probably are not visible. However, it's a non-issue because we'll now take some small measures. And now here we try to write a test. Test, then we reduce it from then, here it is. Let's remove the full screen. Then we will connect, after which we will take appropriate measures to make everything clearly readable. The reason I am doing this, even before starting the exercise, is that obviously it requires a bit of time, and so I prefer this part to run in the background without impacting there. You see it started, now I use another feature of VirtualBox. You see I enlarge the window a little bit. Let's say more or less a resolution like this. Keep in mind that here the entire resolution is 2880 by 1008, so the resolution is very high. I take a bit less and then I do something like this, scaled mode. And you see that it seems like nothing has changed. But if I do this, and then I enlarge it, you see that it increases in proportion. That is in what could be called scaled mode. Okay. Now we leave this here for a moment. So let's start by looking at the exercise we left off last time. So the exercise from last time was actually very simple. It asked to create a directory tree, which is also simple. As you can see, the subdirectory created in this way. Then it said to create in C a file called pipo.txt and then move to A using the command CD. And then from A, write the command to copy the file that is in C, copy it to D, thus without being in C, both with paths, that is, relative paths. I remember that the relative path is one that does not start with a slash, and with absolute paths, that is, those that start with a slash. Okay? So let's say we can proceed. Let's go here. Now, how can we create something like this? I told you I would take the opportunity to show you the Macintosh in action. So you see here we have what is called Finder. If you notice up here, this is a legacy of the old Macintosh, because the old Macintosh operating system was not multitasking. It had a system called Finder, and this has remained for compatibility reasons. You may not have seen the old one, but maybe it's possible. And so we have this. Obviously, then we have the terminal. Okay, so first of all, let's see where the terminal is, because if you have the standard installation and you have the Macintosh with the standard installation, you don't have the terminal icon here. Now, how do you see the terminal icon? You go to Applications, then scroll down, and you'll see that at some point there is Utilities. There it is. And inside the Utilities, there is terminal.app. So you either start the terminal, or even more conveniently, drag this icon here to the bar, like I did, and then launch it from there, which is obviously easier. Well, now we have launched our terminal. If you want to enlarge it a bit, because it's too small, press Command plus, and it enlarges just right. Now, a few words very briefly on what the terminal is, because last time we also saw in quite some depth how to use the terminal, but I am taking advantage of the fact that this terminal is a little different from the one on Linux, although obviously almost the same, to give you two pieces of information on why these terminals exist. Because I expect that many of you simply have never seen this type of terminal, or if you have seen it, you have seen it in a very approximately. Okay, so keep in mind that terminals originated many years ago when these graphical interfaces simply did not exist. Remember that graphical interfaces were born, let's say, at the beginning of the 1980s by the initiative of research laboratories in Palo Alto, if I remember correctly. And then the first company that actually used this type of interface on commercial computers was indeed Apple. Okay, I remember in the early 80s, I think it was 83, here in Turin there was a sort of, in short, technology fair. Now, I don't remember exactly the name. I remember going there and I saw this, the first Macintosh, one of the first Macintoshes in action, with its graphical interface, with its mouse. Then, in the 1990s, even Microsoft began to use them heavily and started to implement graphical interfaces. And since then, obviously graphical interfaces have spread in a way absolutely total. Many years ago, computers were first of all enormous. So for example, they needed an entire room, and moreover, they didn't have any kind of graphical interface. So how did one control a computer? You could go directly into the room and perform almost mechanical operations on the computer itself, but the need to control it remotely quickly emerged, because naturally it was inconvenient, very inconvenient. And by being able to control it remotely, it could also be controlled differently. To perform this task, something that was already being used was utilized, which was the Telewriter. Perhaps some of you may have heard of it. The Telewriter was a system for managing, for sending messages, if I remember correctly, in Morse code. So essentially through the telegraph, but automatically. So you had a keyboard, you typed on the keyboard, and then on the other side there was a printer that wrote the result. And so you typed. And on the other side, whoever was responding to you was writing. A sort of early chat. Now, obviously, teleprinters had been around for a very long time. I think about a century from now, maybe even more. And so this system was used. Since in English telescrivent is called teletype, here we have exactly this, a terminal. Now if you give the command TTI, TT stands for teletype, it tells you that you are connected to this terminal. This is a directory to indicate the devices. But this is a detail and this is the terminal. Now in the meantime, Linux will have started correctly because I also need to launch the installations, so I take advantage of it. Bear with me, but it's the only way to get everything done, because my goal, as you will have seen, is to accomplish everything, so to speak, in a single take, because in this way you have the possibility to create and then do the same things I did, and you have the guarantee that if you do what I do, you get the same results, except obviously for errors and omissions, but in general you have a good guarantee. If one were to make an edited video, clearly there could be problems, because errors come out in the most famous films, let alone in a video made by me. Now, terminal. Very well. Here you see, we now have our terminal. I remind you that if you want to enlarge this terminal, you can do Ctrl plus instead of CMD plus. But essentially, it's the same if we enlarge it again. Now, if you give the command W, which means who, it tells you that there are also terminals here. In particular, this one. This 2.0 means the console, and this is the terminal. Essentially, you are logically connected to a teletype writer that is connected to the console being the computer itself. But you see that there are also some interesting commands in Unix. For example, this one, which doesn't work here, but does on the other side. It depends a bit on the Unix dialects. There's also another one called PS, which we haven't seen. You see it's used to see which processes are running, and you see it says PTS here. If I do man PTS, the manual page is called man init. You see that it tells me what PTS are. It tells me sudo terminal. So this is, let's not worry about the details. These are sudo terminals. Why pseudo terminals? Because the terminal in the past was effectively a teletype writer, while this naturally is a pseudo terminal. Then over the years, the teletypes were replaced by actual terminals. They were like televisions, often with green phosphors, with a separate keyboard. I used it for some years. They were a bit special, a charm from the past, and obviously they are no longer used. However, the concept of terminal has remained because configuring the computer is much easier and more effective through the terminal. Graphical interfaces are much more convenient, but only if one has to perform operations that are typically not particularly repetitive. Yeah? If one needs to perform repetitive operations, often keyboard shortcuts are more convenient. That is, paradoxically, using a keyboard. Let's say this was just to give you an introduction, to help you understand where these terminals come from, which would otherwise seem so strange. So they are still present and absolutely essential for anyone using a computer, which is why I have emphasized this point. Now, in the meantime, as we proceed with the rest, I wanted to continue with the installations. So, one of the things I should install is adesso a program called the GIMP, which is used for editing images. Here, you see, this is a problem that occurs because, in my opinion, it is trying to download the updates. Now, we will solve it in a not particularly elegant way, but we proceed in this manner. We restart. Unfortunately, it's not very elegant. Okay, but luckily we have things to do. So the first thing to do was to perform the exercise. Well, now, you see that if I give the command pwd, it puts me in user Montrum, meaning in my home. Okay, since my user is called Montrum. So to create this directory 3, I would suggest going to the desktop, because going to the desktop makes it easier to see, right? We can also view it with Finder. Note that on Windows, Finder is called Explorer, not to be confused with Internet Explorer. Excuse me a moment. Yes, this is starting. So let's go to the desktop. So cd desktop, and you see that here we have exactly the same files. If I enter the two options on the command line, which are ELE, where L stands for long view and A stands for all, you see that it shows me a whole series of things. Okay? So let's start by creating the first directory, which was directory A. Okay? You see that the directory appeared immediately. Now we go into A and do mkdir B, and then also mkdir C. Okay? Because you see here we had A with B inside and C inside. Well, now the exercise said that inside C we need to create another directory D. So we could do cdc and then mkdir D, but we could also do something like this using a relative path. we do C like this, okay? So the directory C is already there, and then we write D. It's good, done. This way we created this directory without moving. If we open it, you'll see that it's here correctly. Well, at this point, we are in the correct position to create and basically to do what we want. But the first thing we still need to do is create the file. So I go into B. Wait a moment, I'll go check if this has restarted. So, test. I naturally remind you that here the user, and also when you'll have the virtual machine available, the user is called test and the password is called test, something that naturally clashes with the most basic security standards. But obviously, this is only a test environment, and therefore, if you want to use it for reasons, because of course no one prevents you from using this virtual machine to create programs or even to browse the internet, to do whatever you want, the first thing you need to do is change the password, okay? Change the password. By the way, you can do it. Now I'll also show you how to do it. There is also the graphical system, but it's much quicker with the system, right? So you see there is a command called password. You see that you need to enter the current password, which is test, and then it will ask you for the new password. It will ask for it twice. As a general rule, excuse me for a moment, here it is. All right. Okay, so here we are. As I was saying, I wanted, let's see if it's still in the history. Yes, you see it's still in the history. Let's see if I managed. Okay, now it seems to be working. Well, meanwhile he manages, here it is. You see the reason why. You see here, it says updated software is available for this computer. It was basically performing a check to see if there were updates to install. Now, I won't install them here because, as you see, they are 360 megabytes. It would slow everything down a lot. We don't need it. So, as if that weren't enough, I don't want the virtual machine to become too large, because if it exceeds 4 gigabytes, it becomes difficult to copy it. So remind me later, and then we'll see. Now, we'll let this install, and let's go here. So, I was telling you, we are inside B, and therefore we need to create the file pipo.txt. So, as for editors, there are many. System administrators usually use an editor called V, but in this case, we'll use this other one that is more comfortable, pipo.txt. Here we write writing test, period, then we save. You see that below there is a whole series of shortcuts. This means Control X. So we click *X. It asks me if I want to save. Yes. pipo.txt. Yes. Perfect. So you see that if I now do lsmla, the file pipo.txt exists and is 20 bytes. Okay? So if I do cat pipo.txt, this comes out, which is obviously very simple. Sorry, I'll go again. Yes, it's finished here. So I'll proceed with another piece of installation. Since for Python we'll use a couple of libraries that are not normally installed, I need to install them. But to install them, I need to first install a library manager. So, and this library manager, it's called, you see, Python 3, because we will use version 3 of Python is called pip, essentially. So the first thing I need to do is install this library manager. Now he proceed, well, so you see that we have created this file now to complete the exercise. Let's go to A, then we go to A, just this once, with an absolute path. Then I type cd, and then I write users. Notice that I used a capital U. Now I try to press tab, and you see that it expands for me. Then I write M, try to expand it, okay? Then I type a capital D, and try to expand it. Nothing happened. So if I press tab again, it gives me the options, somewhat, like the systems used in cell phones. Then I add an E, and the E. You see, solves the problem, because the others are O. So I press tab, and at this point, I'm there. Okay, and so I'm there. Then I added an A, and I'm exactly where I wanted to go. Actually, it was done earlier in another way, but it was enough to use a CD But but we want to try like this. Sorry, I keep checking. You see, it's installing this object. It asks me if I want to be sure to restart certain services. Which services in particular? It's the web server, because if you remember, we finished installing a web server, even though obviously we have just seen it, but let's leave it there in their place. So here it's fine though. Okay. You see services restarted correctly. I also remind you that there are also Italian versions of Linux. I strongly advise you against installing them, because the translations are never exceptional, and I recommend you stick to the English version, which is much more convenient. So let's continue with the installation. At this point, I need to install the libraries I need. Here I no longer need sudo. So the first library is called All Your Days. This one is used for managing binary numbers. And not only that, but let's say that's what we need now. Well, then we need to install another one called Matplotlib, as you can understand. Yeah, it is used for making mathematical drawings, in short, plotting graphs, etc., because we will need it in the next episode. Okay, now this will take a little more time. Let's move on. So basically, we went to A, and at this point, we need to complete the last part of the exercise, which involves copying people.txt. I remind you that people.txt is sorry. People.txt, yes. It was inside B. Sorry, perfect. Yes, actually, well, we did it inside B. It should have been inside C. But anyway, it doesn't change anything. Okay, so let's copy it from B. So we use cp and use a relative path. So bpeople.txt, all set, or even better. This way it's a bit more complicated. Since we need to copy it into D, we say ctab, dtab, and we're good. Okay? Now, if we go here, we do it like this. And you see that people.txt is in its place. Okay? Now we want to do the same thing. So to begin with, let's delete the people.txt that is in D. Then rm, c, d, people.txt. Notice the use of tabs. Well, and so at this point, I first of all do, okay, sorry, just a moment. Let's install the other library. This is a library for scientific computation, essentially, because Python is extremely suited for scientific computing. Actually, Python often relies on libraries written in C, but the result is that it is very convenient to use. All right. So with this, as soon as this is finished, we will have installed everything we need. All right. Then now, what happened? As I was saying, there are always problems lurking. It might be a connection issue because you see it says read time and out. Damn. Okay. So in these cases, one can try again. Notice that here I have a control system. You see that it's downloading at 1.2 megabytes per second, and at the same time uploading at about 20 kilobytes per second. So it means, you see, now at this moment it has finished doing. You see it worked. Computer science is almost exalts. Okay? Almost, for your curiosity, see that here I have a whole series of sensors which are also under Linux. You see, this is the power consumption we are using at this moment, about 50 watts. Usually it's much less, but right now we are using the webcam and the microphone. And then we are also mainly doing the recording. Note that the recording is a big problem because we have a nominal resolution, which is the monitor, 2880 by 1008. but we are recording the file at 1920 by 1080. So we need to resize everything instantly on the fly. And that's why the CPU, you see there's a certain amount of CPU usage. You see 40% used by OBS, which is the open source software I use for recording. So you see the installation worked. So we should have everything. We just need to complete the exercise. So excuse us, here we are. So now I want to make another copy, but with the absolute path. So I do users, you see I typed it in lowercase, then hit tab, and it took USR, which obviously isn't what I wanted. So users mon2, desktop B. No, sorry, as I said, to dpeople.txt, okay. And then the other absolute path that actually repeats, but now we have to do it so to cd. Okay, so if you now see that here we have ptxt and inside we have ptxt. Okay, now let's say that this directory actually is no longer needed. Okay, so we are still in a let's go back by one, no? And we want to delete this directory A because we basically don't need it anymore. So how could we do it? See, we go here, right click, and then we do move to trash. I remind you that doing move to trash does not mean deleting it. It means changing its name and putting the new file in a specific directory, which is why it can be recovered from the trash, because otherwise it is indeed a trash. If you throw away a sheet of paper and put it in the trash, it's not that you're pulverizing it. You've put it in a trash bin. Instead, I can, so to speak, destroy it. So to destroy it in a way, in such a way that it cannot be recovered anymore, even if this is not completely true either. I can use to command rm. Okay, so here I have, you see, I have a series of things. If I do RMA, it could delete it for me, but you see it tells me no, it's a directory. Okay, so I could do rmdir, but even here it tells me no, I can't, because the directory is not empty. But I'm stubborn. I absolutely want to delete everything. So I do something like this. You see, I put two parameters on the command line, two options. This R stands for recursive. So it deletes even in the subdirectories, and F stands for force, meaning go ahead, delete everything. Okay. You see that the water is gone. And here it has also updated the Windows content because that directory A has actually disappeared, okay? Well, with this we have completed the exercise. So, all right. So I wanted to show you one more interesting thing, useful there. So we have finished everything. I would say we're done here. So let's start preparing the rest then. The first thing we need to do is start Firefox, because I also want to have Snap at the same time. Snap. By the way, right in the period between the recording of the first episode and this episode, version 5 of Snap was released, which incidentally doesn't have major differences. So just as a test, let's try using it. Okay, well, last time I suggested launching it, downloading everything locally launched from local, because it's faster. A lot of advantages. Here we try to launch it from the network. So now we are using Snap, but beware, it wouldn't work. If we didn't have the network now, just for your curiosity, you'll see that inside control, a voice that wasn't there before has now appeared. Okay, but for the rest, there aren't any particular differences. Nothing special. Okay, so at this point I lower this a little. I will take this other terminal. So here I want to enlarge this terminal properly. So you see, I keep it to 80 characters in width. So I'll widen it a bit more. They're 80. Perfect. Then I'll put it here. Maybe I'll reduce it slightly. Well, let's leave it like that. Okay, and then I'll make another one. Let's press Ctrl plus, so we have two of them, so as to show both C and Python at the same time. Okay, good. So for the moment, I'd say we're all set. So basically, oh yes, I wanted to show you something. So let's go on this. Here it is, what I wanted to show you. So this is a very normal USB stick, but with a special feature. You see it is dual standard. Now they are starting to become common, USB and USB-C, so USB 3 and USB-C. It's very convenient because almost all modern computers have USB-C. Now let's try to insert the USB stick to see what happens at the operating system level. So just a moment. Be careful with the pills here. Okay, the flash drive is inserted. Here you see that it has recognized it, and here is the content of the USB stick. Or if they want, of course I can go here, that's fine, but up to here nothing special. But I want to see it, I want to see this USB stick from the terminal. Okay, so I am still here. I told you that under Unix, I remind you that the Macintosh, the Mac OS X, is indeed Unix. It's a dialect of Unix, so to speak, because Unixes are all slightly different from each other. There are even differences between different Linux distributions, but they are dialects. So let's say if one are not very different dialects, it's like if someone from Piedmont goes to Turin and then to Alessandria. Yes, it's true, there are a lot of different words, but all in all, you can understand each other. Okay. And here it's more or less the same thing. So we want to find out where the USB stick has been mounted. Okay, you see that if I give the mount command, it tells me that this is the stick. This is the name of the device. We won't debate that. And this is where it's mounted. That is on the part of the tree where it's mounted if I do CD volumes. 32 gigabytes are on the USB stick in all respects, okay? Well, no, that was just a very quick test. I want to try to unmount this USB stick, okay? So just like there's the mount command, there's also the unmount command. Okay, so let's try it and see if it works. You see it says operation not permitted. So one might say, oh, well, maybe it's because I'm not root. Okay, I'm not the administrator, so let's do sudo. As I've shown you many other things, it asks me for the password. And no, it tells me resource busy. Well, but I'm sitting here on the drive, and so it's like I want to remove the chair while I'm sitting on it. So let's do cd. So it takes me to my home, and let's try to give the command again. Nothing to do. Notice that it didn't ask for the password again, because let's say it accepted it, but it gives me a suggestion. Okay, notice that under Linux it would have worked, and I do with lots of commands that, and then I do volumes. 32 gigabytes, and this time it worked. You see that it deleted the window and also removed the icon. Okay, so it basically works. Okay, now we'll see the same thing also from Linux. So let's go on Linux. Perfect. So the first thing we need to do is get the exercise materials, because up until now in the first 2 episodes the exercises were essentially files that were actually written on the spot, created on the spot, but here obviously we don't have the capability to do so. As I pointed out to you earlier, I have a file here that contains everything we need. Okay. Now, however, this network model, I remind you that VirtualBox has its own network model, because these are virtual machines, allows the virtual machine to communicate with its host, but does not allow the opposite unless you do something called port forwarding, which we will disregard. So in theory, to be able to take this file, bring it here. I would have to take it from here to there. How could I do it? For example, with a USB stick. We'll see how now. Or with that shared directory. We had already seen that. Or even if you install everything correctly, you can even drag and drop. That is, take the icon and drag it. But now I want to show you a method a bit more refined, because that one is easier. But here we are. We are here to learn some things now. What do I want to do? I want to try to contact from the virtual machine the lost, because I couldn't do the opposite. Okay, so the first thing I have to do is make sure that the Macintosh responds to me through SSH, because if it doesn't respond to SSH, we're stuck. Okay, so how can I see something like this? You see here we are looking at things a bit more, so to speak, system related. Okay, so here there's an option for sharing. Then here it is locked, actually, because naturally it is needed to prevent accidental changes. You see that it says remote login here. So what does remote login mean? It means that if I now take this and move it a bit further, okay, and then I execute SSH, and naturally we need to know what the IP address of the Macintosh. So here it tells me, sorry, a bit, here it is. You see here, there are many network interfaces. You see many are usually virtual interfaces related to the fact that almost all modern computers have the USB-C port. And so the network adapter is mounted directly onto the USB-C port. So anyway, these adapters grow like mushrooms anyway. This is it's the address 13192 prefix of the Polytechnic. Maybe I already mentioned it last time. Okay, so what interests us is this 559. And we are going to put it here. We'll keep it aside. Well then, what are we trying to do here? Well, we're trying, you see it says remote login here, and there is a check mark. So if you see that it says remote login to this computer remotely, maybe you can't see it in the video. I'll enlarge it a bit. To log into this computer remotely, type SSH Montreux. Okay, this is the registered name. All right, let's try it, SSH Montreux. The IP address, we have the name, but only up to a point. So let's proceed with the address to be sure. It was 159. So he says to me, are we sure it is? But yes, we are sure. Okay, now I enter my password, and you see that I'm in. And as I had already shown you, it worked. Okay, it worked correctly. But how do I transfer the file? I can't. So we exit from here. I remember it's done with exit or log out, or I did Control D here. But let's try to see what happens if I remove this check mark. Okay, and off. Then we block it, and now we try again. You see that now it basically doesn't work anymore. Okay, so now we stop this here. We can't do it anymore. We unlock this. It needs the certification, and then we do this. At this point, it should work again. Okay. All set. But as I was saying, it's not enough for us, because with SSH is a remote connection. Okay? SSH stands for secure shell, so it's a secure remote connection, and let's say it's one of the safest things in computing today, SSH. Well, then we do CtrlD, but I need to transfer the files. We don't need this anymore. I need to transfer the files because I want to connect to the host computer, the Macintosh, and copy this file. Now, to transfer files, a protocol called FTP is used. FTP stands for File Transfer Protocol, okay? FTP, okay? It works, but it's not what it is, because for a whole series of reasons, mainly for security reasons, FTP has been disabled. However, there is SFTP, which uses the same structure as SSH. So S stands for Secure File Transfer Protocol, the same.
So if you have SSH, let's say if there's the SSH server on the Macintosh, there's also the SFTP server, because it's actually the same thing. So I show, actually let's do this. We retrieve the history. This way it's more convenient. And here we write FTP. Okay, at this point we enter the usual password again. And you see that here where I am in my home directory. Okay, because it connects to my home. Now the problem is this is an important thing. So here we have a program that is connecting to another machine. So it is here, we have launched the SFTP here, and this is the so-called local, meaning local on the Linux machine. The remote is the Mac machine. So if we do ls, we do ls of the remote. Okay, if we want to do ls of the local, we precede it with, you see, an exclamation point. Okay, so this is the local ls, but be careful because local and remote depend on who launched LSFTP. If I had launched LSFTP from the Mac machine on the Linux machine, the local would have been the Macintosh and the remote would have been the Linux. But I didn't do it because the Linux machine would not respond to me due to the memory model. All VirtualBox, but this, so to speak, are details. Okay, so now I want to go into the desktop because the file I want to take is on the desktop, and I also want to move the file on the Linux machine back to the desktop. So then, if we do cd desktop, which space are we moving to? We are moving to the remote space. Okay, so now you see that the file is there, but I also want to move locally, and I need a command called lcd, which stands for local cd, which would be the equivalent of an exclamation point cd, and I do desktop. Now you see, if I do ls echo, as it tells me that I am here, that is on the Macintosh desktop. If I do exclamation point ls, it tells me that I am on the desktop of the Linux machine. Perfect. At this point, I just need to get the file. LFTP has activated a connection, this bidirectional connection, meaning I can take things from the remote, so from the Mac. I remind you that it is always bidirectional. From the Mac to Linux, or from Linux to Mac, as I wish. Okay, for example, I want to take the material for the introductory course. So to get data from remote and bring it locally, I use the command get. Okay, I type then tab because it recognizes it. Okay, now you see that it's downloading it over the network and it has downloaded it. If I wanted to copy something from Linux to the Mac, I could do it still using the same connection, but I would need to use another command, which is put. Let's try it then. You see that I have some tabs here. So I'm, for example, where am I? I'm here. I go to my desktop. Let's create a file, just a file to transfer. So to create a file, you use a command called touch. Okay, touch people. Notice that inside people there is absolutely nothing. And if I do lsela, you see that people is 0 bytes. So it's a very virtual file. Now we have a file available. Okay, in fact, if I do ls with the exclamation point, you see that now there is people. So I can do put people. Okay, at this point it moves it for me and it should be placed here. There it is, you see. Here it is, you see, it has no extension. It's nothing, a file of no importance, but just to show you how this mechanism works. Okay, so basically what did we do? We went and took the material directly from the other machine via the network. Notice that this SFTP works with any machine on the internet. The only thing is it must have an SSH server, and you obviously need an account to use it. So it's not that obvious, but SFTP and FTP in general are extremely common protocols. So we can exit, we type bye, and we exit, then we type exit. We are in the home, we go to the desktop. Yeah, all right, we can remove people because we don't need anything. And this is the zip file. How do we unzip it? We do unzip materiale, and you see that it unzips it. And at this point, we also have a directory you see that the colors indicate different things, and so we do CD Materiale and we are inside the directory. Okay, then we do the same thing on the other side, because I want to have two tabs, one for IC and one for Python. So there's already CD Material. Here it is, and so we are all set. Well, then I still wanted to show you one thing. Wait a moment, that here, maybe, so this one here, wait, made a bit of a mess. A bit of a mess, so we're going to put this somewhere else since we don't need it. Then we also put this somewhere else. Well, then what I still want to show you, and then we can start doing all the other various experiments. What I still want to show you is that what happens when you insert the stick under Linux. Okay. Now this is interesting from my point of view, because the stick is still stuck on the machine. On Macintosh, now I will remove it mechanically. Okay, then I will reinsert it since we are at it. Let's delete this file, people, so everything stays organized. Okay, you can see that it placed it here for me. You see it's called people, but actually this file doesn't exist because it should be then else the file should be here. It should be here somewhere. Here it is, seaside.thresh. Here it is. See the file, people? You know, it hasn't been deleted. It has been moved inside a directory called thresh. So since we don't want to delete it for real, we empty the trash. Yes, we are sure. And so here, if I do ls again, now you see it tells me there is nothing left, because obviously it has deleted it. Okay. This was just the mechanism. It's the same also on Windows. Now let's see about the USB stick. I have removed the USB stick and now I will reinsert it mechanically, fitting it back into the USB-C port. And at this point it recognizes it on the Macintosh. Here it is. You see it recognized it. So if I do this now, I can do whatever I want. We saw this before. Now we unmount it because I want to connect it to Linux. That is the virtual machine. How do I connect it to the virtual machine? So I start by unmounting it here. Okay, notice that the USB stick is still mechanically on the laptop, obviously if I haven't removed it. Okay, I need to find a way to attach it in here. I have to tell it, I have to explain that it needs to attach this drive. So I exit the scaled mode just for a moment because I need to access this bar down here. So you see there's the USB icon here, and among the various devices there's the drive. Okay, so I do this, and you see that it starts flashing. See, it starts flashing to indicate that the USB stick is working. Now I will return to the enlarged view here so it's more convenient. Okay, if I move this thing over here, you see the drive has appeared. Okay, but I don't want to see it from there. I want to see it, let's keep it a bit exposed like this. I want to see it, for example, from here. So I mount it, and you see it's amidst a whole mountain of virtual file systems at the very end. Sorry, here it is. You see that here is my USB stick. Notice that the name of the device is very different from what was on the Macintosh, but obviously the USB drive is the same. So if I do CD media test 32 gigabytes, you see that I'm on the USB stick. Okay, now let's try to do as we did before, a mount. Media test path tells me no target is busy. Okay, but as I said before, it's true that we sat on it. So let's do it like this CD, so there's no more problem. let's try again. It worked. You see, the two Unix systems are a bit different, and so here it's allowed to do this kind of operation. It's not a big difference, to be honest, but it was just to show you that they are both Unix but slightly different. Okay, so let's say I am just checking that I did everything. Good, we have completed the installations. Good, good. Good. Okay. So at this point, I would move forward with the Raspberry part so we can manage our time better. So now we take this virtual machine and freeze it. See? Pause. We put it on pause. You see it turns all gray, right? It doesn't cause any problems. It generates no issues and it's fine, okay? Now this, I wanted to do something like this because now we're going to do something a little more, so to speak, a bit more sporty. So we take this and we put it here so it doesn't bother us. Let's put this here because it is convenient for us, okay? Very well. So what did I want to show you? I wanted to show you something a bit special because until now we have basically seen a Windows 10 machine, and then we saw a VirtualBox with which we loaded Windows 10 and also Linux on board, and then now we've seen a Macintosh. Notice that the processor with which both this computer and the other one operate is the same. It's the same type of processor, not the exact same one, but it is the same type, an Intel. Okay. However, in the world, there are not only processors of this type. In fact, to be honest, most processors are of another type. Yeah? In particular, the most widespread processors in the world are those found in cell phones. But they are not only in cell phones. They are also in washing machines, televisions, multimedia devices, car radios, everywhere. Now, what type of processor is there? Let's go here now. So so here we go. Now let's remove this sheet that we don't need anymore. So what would I like to show you? I would like to show you this little object. So with the so this little device is, you see, Raspberry. Probably some of you have heard of it. I have a certain number because I use them for exercises in other courses. This is a new box. See, this is the little board. See, it's new. Now we'll see it in operation, of course, because seeing it in the box is not very useful. This object costs about 40 euros. A few days ago, version 4 came out, which is definitely more powerful, has more memory, faster, etc., etc. But for our purposes, it's perfectly fine. So this is the exact same Raspberry, simply placed in a plastic case to make it more convenient to handle, more robust. Now, here you have the network port. So you see, this is a network port. These are 4 USB ports. Then we go to the side. Here there is nothing. Then over here you see an SD, and this is the hard disk of the computer. After that, on this side instead, this is the HDMI to which you can connect a monitor. This is the power supply. It's a mobile phone charger. And this is the audio, okay? We have already seen this part, okay? Be careful because the power supply in the Raspberry is a bit critical because for technical reasons, due to the voltage drop on the power supply wire, the classic 3 volts might not be enough of the USB. So sometimes there are problems, but let's say we shouldn't have that problem, okay? The power supply that comes with it obviously doesn't have this issue. Now, in addition, you see those are the processors. These are small heat sinks, which aren't in the other one. And this is a very important little item. You see they are essentially pins, okay? And they are called GPIO, General Purpose Input Output. What are they for? They are for connecting the Raspberry to a whole series of objects. I don't know if any of you might have tried some experiments with Arduino. Well, it's very similar. This, if we want, is its bigger relative, okay? Much more powerful. Now, inside here, there's a 64-bit processor, right? With several cores, okay? So it's as if there is more than one processor. Basically, this device has the processor that's in a latest generation phone with appropriate power. So how can you use it? Well, first of all, you need to connect the power supply.
Okay, this is, as you can see, a very normal phone charger. Okay, well, then you could connect a monitor and also a keyboard with USB, okay, but here we don't want to do that kind of experiment. Instead, we want to connect it to the network and access it directly from the Macintosh. So we connect it to the network, this somewhat beat up network cable, but let's hope it still works. Okay, well, so we put it there. Then on the other side, I disconnect the network plug that actually goes to the internet from my office and attach the cable connector. Because you see that I have this cable here. It's a single cable. You see, it's simply a point-to-point cable. You see a single cable, okay? Once upon a time, you needed cross cables, but now it doesn't matter. Now I'm going to place the cable and slot it into my network socket. So, all right, at this point, I turn it on, which means I connect the power. Okay, you see that it has turned on. And since it is a full-fledged computer, it should start now. We hope to make it work. If it should have started correctly. If you notice, wait a moment here. Okay, you see, these are the network lights, so it's communicating with my laptop. All right. At this point, let's try to make it work. Okay, let's move away from here and go there. Now, here we are, more or less in the usual place. Okay, we want to connect to the Raspberry. Okay. However, we have nothing available except the network. Now, what do we need? We absolutely need a protocol for the connection. The protocol, in this case, is the SSH. Naturally, the Raspberry, when it arrives, needs to be configured here. It's obviously already configured. But I just want to show you, let's say, the result. Okay, so we try to connect using SSH. Okay, then the user up there is called P. Well, anyway, this is a detail. And then I set the address when, let's say, I installed the operating system. On there, there is an operating system called Raspbian, which is essentially a derivative of Linux. Okay, so it is a Linux in all respects. Even there, as I was saying, a dialect. So it's not exactly the same thing. 5.1, 5.2. Because I gave it this address. Okay, you see that it works. Now it asks me for the password. Let's see if we can enter it correctly. Okay, I did it. Okay, you see that I connected. It works exactly like the other one. If I give this command, for example, it tells me the type of Linux that's installed. Okay, but the interesting thing is that it tells me this thing here, ARM, so there is no Intel on this. There is an ARM processor. So this means that the Linux operating system is able to run on different processors without any issue. Okay, and indeed, if you think about it, Linux is certainly the most used operating system on the planet from this point of view. Because I think that, you know, not so much Linux as Unix, because I believe that you all know that since by now, cell phones based on Windows have practically disappeared. This means that almost all cell phones are either Android, and Android is a derivative of Linux, or iOS, and iOS is also a Unix. Okay, there is still something I need to tell you once we've finished this, because it seems interesting as well. So at this point, we are above. Everything works regularly. We can, for example, launch things, do a bit of whatever we like. Okay, and at this point, for example, I wanted to show you, you see that just to complete the little game. Inside here there's a directory testasm. Okay, well, just 1 minute. You see that this file first S is a file written in assembly. Now assembly is the language of the processor, okay? This program is almost useless. It puts the number 2 into a register and then exits. That's it, nothing else. This is the register that is read when the program ends. To compile it, I can use GCC, or even simpler, I do make, and it does everything for me, okay? If I run, make clean, it deletes it. You see, if I then run, make it, recompiles it. And in this way, my file is called. First, you see this here. So if I run first, it does absolutely nothing, actually. It did do something, because if I do this, it tells me 2. So this here is the return value. What is this return value? I'll throw it out there. When you, at the end of a program in C, or possibly even in other languages, do a return, that is, you return something to the caller, that is the value, okay? Now it was just a little game to show you how indeed one can range from assembly to any other language. These examples are due to the fact that I use assembly for another to make the exercises of another course, that's it. Now, however, I still wanted to show you something about the operating system that comes along, partially pre-installed. There's also Mathematica. What is Mathematica? I don't know if you've ever heard of it. Mathematica is probably the most powerful symbolic computation software in the world. Okay, in the sense that it is able, for example, to perform indefinite integrals with very high power. Now, Mathematica is a graphical program because naturally it needs graphics. Okay, well, here I tried to launch it, just like I could have launched code.blocks, or I could have launched Firefox. Okay, the problem is that this program is running on the Raspberry. And how can it show me the display here? It can't. Okay, n'affecte del sector G optitunaast. It tells me that at the top end display. But I could say, okay, can't you let this display pass in some way and make it appear on my display, the one on the laptop? Yes, within certain limits. It can be done. Actually, it can be done. But I got the command line wrong. Okay, you see SSH so far we've used like this. If I want to use the graphics too, I have to add an option called -y now. Let's not argue too much, then 15. Let's see if I got it right. Yes, I got it right. Now I have connected in such a way that the graphics are also transmitted. Over this channel, the SSH has an encrypted channel, so even if someone intercepted the data, they wouldn't really be able to do much with it. Now, unfortunately, the speed here leaves a bit to be desired. But now, we will manage. Now, before ending this episode, it still takes a few minutes, because I wanted to talk to you about something else. In fact, I would almost move on to talk about this thing. So meanwhile, here you see, in the meantime, he started the X server. There, he succeeded. Okay, you see this X here, X11. Note that to make it work this way on a Macintosh, it requires some extra tweaks. Okay, on Linux, it would work without problems. Okay, on the Mac, it requires some extra tweaks, but it can be done anyway. Let's say that it's not the case too. Let's say you need a command that I'll write here for you. Something like sudo. Obviously, there is also on the Macintosh clearly install xorg. Okay, this is used to install this X1 server. See this here, which then manages the graphical interface connection. Note that the Macintosh has a different system for installing commands, just for a change. Okay, that's why I was telling you they are dialects. All right, anyway, let's forget about this. Let's try again. Let's try running it and launch it in the background. Okay, you see, at this point it no longer shows the error message, and you can see the graphical interface of the mathematics appearing. Now, this is something very refined, very significant. That's why I wanted to show it to you, because we are seeing on the laptop a graphical interface of a computer that at this moment doesn't even have a keyboard connected. It doesn't have a keyboard. It doesn't have a mouse. It doesn't have a monitor. It has nothing. Yet we are using the interface, and this is through the use of the terminal, because we use the terminal. So this was the system that was used and is still used to connect to remote servers. Now, this is the mathematics. We're not going to look at it now also, because to be honest, I'm quite rusty, but you see that here, if you want, you can check out a lot of things. Do integrals. You can write an equation. It makes the graphs for you. It's wonderful. Anyway, let's get out of here. Now you see that I have finished here. This part is done. You see it wrote done. Perfect. At this point, however, before disconnecting the power supply, I have to turn it off. Okay? So I use sudo, because I am not root. And then to turn it off, I have to use a command called shutdown, from English. Send down. Okay? -H now. Okay? H means halt, that is stop it. And now means immediately. Okay? You see, I do something like this. And it tells me that the connection is closed by remote host, because the remote host is going down. If we go here to look now, you see the LEDs are still blinking, because it means that the system is shutting down. Since obviously it doesn't have the power of a Macintosh system, because it's an excellent processor, but it's a mobile phone processor. Keep in mind that these are processors that consume little current, because we are talking about the consumption of this power supply, which is not at all comparable to the consumption of a traditional computer. Okay? Now it is shutting down properly, and so we are done here. Now to end the episode, so that next time, in the second, sorry, not the episode, part 4a, so that in the next 4b we can basically see the various files, the various examples. I still wanted to show you something that I think is important. Here it is. So you have probably noticed that here it is written, this work is licensed under the Creative Commons license, and therefore it is written UCCC by ESA. Maybe some of you have wondered what this licensing model means. This is the system, the licensing model with which I normally release my educational materials, so the slides, and in this case also the videos. Let's say that the videos are not so common. Okay, so this video has that license. What does that license mean? It means that CC stands for Creative Commons. It means that they are materials due to creation, not creativity. Okay? This by means attribution, it means that you can take this video as well as the slides, copy it, distribute it on your own, do whatever you want, basically, because you cite the source, okay, who created it. All right. Furthermore, there's this ESA. SA stands for share alike. No? Okay. What does live by mean? It means that when you distribute the item, you can also cut parts of the video, no problem, and distribute the individual pieces or do an editing. It's all fine. The only thing you absolutely must say is who the author of that piece you took is, and then the new piece. So the piece you have cut, plus what you have added all together, must have the same license. That is, it must be in turn Creative Commons Attribution Share Alike. Okay, you cannot edit, for example, make it private. Let's say a company wants to take this film and then edit it to create some kind of instructional video for internal use within the company, and then make it private. The company cannot do that, because if it wants to make edits, it can do whatever it wants, but then it must release it under the same license, so free for everyone. Also note again that this means it is free, and indeed it is called, so to speak, copyleft. That is, in effect, without copyright. This type of license is practically the same as the GPL license, which is the Linux license, where GPL stands for General Public License. Okay, so with Linux, You can also use it for commercial purposes without any problem. You can therefore develop commercial programs with Linux and sell them. In fact, you can even sell Linux itself. You might ask, why would I sell it if I can get it for free? Well, I could also sell consulting services. And indeed, there are companies that do so. For example, Red Hat. They do not sell the product much because the product itself is distributed for free. They sell support for the product. And obviously, there are those who find such product support very convenient. One thing I definitely cannot do is take the footage or take Linux, modify it for my own needs, and then keep it or sell it claiming I made it, okay? Well, but they are not the only licenses out there. So there is another license called BSD, standing for Berkeley. And this type of license is a bit different in the sense that it says, look, you can do whatever you please with the code, no problem. Not only if you want, you take this code, incorporate it into your programs, modify it, distribute it, and then resell it and say it's yours. You can do it. Okay, now you might say, but this license is strange. Not really the operating system of the Macintosh that you are seeing right now. Has exactly, and let's say it started from such a license in the sense that when Apple developed the new operating system, let's say at the beginning of the 2000s, it started from a Unix BSD base. All right, since the BSD license allows, Apple was able to sell it as proprietary. In fact, this is a proprietary operating system, just like Windows. If it had used Linux to do something like that, it would have been forced to redistribute the operating system as well, something that clearly would never have done. Okay, so we have these two types. Okay, here we are talking about open source systems, that is open code. I remind you that in the first episode, we briefly saw Firefox as an example. Open source, in fact, we took a look inside the code just to see. So we have this license that is a bit stricter, this one that is a bit looser, and then we also have others. For example, CC0 stands for Creative Commons 0. This is public domain. It means that I create something, a program or anything else, and then I deliberately relinquish any kind of copyright rights. It means that someone can take the program, modify it, resell it, do exactly what they want with it. Okay, so even more, with even more permissive waivers than the BSD. And then finally, there's another license, which is not really a license. It's a way of distributing software called freeware, meaning you can take the program and use it for free for any purpose, even commercial. However, you do not have the code, so if you want to make changes, you cannot. Naturally, these are the licenses, so to speak. So the program can be used freely, but in most cases, this is not true. For example, the operating system of this computer is not freely used, has some limitations. For example, right now, I don't know, in this right now, but until some time ago, Mac OS X could not be installed within a virtual machine. It was prohibited by the license. Instead, for example, Windows can be installed inside a virtual machine, but it is also obviously restricted so much so that I will distribute the Linux over to you, but I cannot distribute the Windows over to you, because that virtual machine we created with Windows was exclusively for testing purposes. But I cannot give it back to you. I cannot distribute it to you. Two last words, and then we are done. There is an absolutely emblematic case that precisely concerns videos, and it is YouTube. So on YouTube, you find many videos. One must recognize that they have done an absolutely excellent job. Well, these videos have two types of licenses. At the moment, I am talking about July 2019. They have two types of licenses. So one license is the YouTube license, which is quite restrictive. But if you want, if you have a material that satisfies this license, you can also publish the video as CC BY. That is this type without the SA, CC BY. So this means that if you upload a video on YouTube with that license, it means that others can download and use it, whereas normally you cannot do that. Note, however, one thing if you upload a video on YouTube in the CC BY format, it means that you have permission to do so, because you cannot take a video made by others that does not have that license and mark it as CCB, because you would be violating the original license. Okay? Well, then I would say that with this we have finished the 4A. Okay? And so we stop here, and then we will start the 4B, which mainly concerns the section about C/Python. See you soon.